All right. Everything should be up now. Sorry about the delay. If anyone was sitting by in the NIM channel waiting for the stream to begin, I announced the stream quite a while ago. An hour and a half? Yeah, hour and a half ago. And I was just gonna set up some things, and I was just gonna do a tiny little, like I had a sneaking suspicion for day 6. I haven't been able to get it off my mind. I had a sneaking suspicion. I fixed that, and it didn't work, and I just couldn't figure out why. I couldn't let it go. So I looked at the Pietro Petrolongo's solution, not really to see what he was doing, but so Pietro is another NIM using person, so I figured he was probably doing Advent of Code, and he has his own repository. So I basically just copied his day 6 solution, and just ran that just to see what number am I expecting here. Found a number, diffed the two sort of my the obstacle positions. I found the obstacle positions he found. I took one of them. I manually edited my input file, and I manually edited my input file. So one of the positions, let me zoom this out of it. So one of the positions that was causing an error was this one. So we got different results when we placed an obstacle there. And it turns out that, so my suspicion was, for example, in this case, if we are moving to the right here, and then we get to this spot, then my code would say, okay, so move into that spot, check if there's something to the east of us. If there is, then turn south, then go through the next loop. And the next loop would immediately step into the new position, thinking if it was safe, then not see anything and just carry on down, and then it would turn off here. So where his code would go here, see both obstacles, just turn around and go out there, mine would pass through here and go out down here instead, which was obviously wrong. But that was my original hunch, the thing I thought was the problem. So I fixed that. So when I moved over, it looked to, well, it basically enters a loop, and then it changes direction until it doesn't see anything in the direction. And that should have worked, right? Like that was good. But I noticed when I did that, my code just started looping. He entered it entered an infinite loop. And what it was doing, it was walking back, hitting this, and instead of going out of the map, it just started going upwards and just entered this loop. Oh well, okay, it's a rather long loop, but basically comes around here, goes back up, then comes here, turns around, went there, and then started going up again. And I couldn't figure out, like, why is it moving up? Like, why did it suddenly decide that this wall was hard? And I realized in my code, let's just swap that back. In my code, part 2, basically two things are going on here. So I fixed the loop, so it's now doing the while true, change the direction until it doesn't find a collision. Super ugly code, but whatever. The problem was actually in my position template. So how I create the position numbers that I use to slice, or that I use to store where I've been, and where I'm going. And the problem here, and I talked about this when I first solved this. I said that, oh, what happens if these are negative? They will just wrap around. The problem was that was if this whole thing is negative, because position is an unsigned integer. The problem here is that this would hit the map width. So that this would be y times map width. And then it would plus -1. So it would subtract 1, which would be the same as being on the line above and all the way to the right, I guess. And if we look in our input, zoom out again. If we look at our input, so this was the problem area. I turned around here, went back, hit this wall, and that basically found on the line above, the end of that line, there's an obstacle. So it basically wrapped around. So it came here and it saw this obstacle all the way over here on the right. And it decided, there's an obstacle there, and turned up. And somehow that happened like multiple times in the code, which was super annoying. And it gave a like semi-plausible result, because it happens sometimes, but not enough times. And yeah, so I solved this by just saying if we're outside of the map in any of the directions, then just use, like, say the position is like the largest UN16 number, which isn't valid for maps of our size. So just give an invalid position, and this position will never be in the set of obstacles because it's not valid. I didn't have to do it for the vector, because the vector is always the position of the guard, and this happens after. So the guard moves, I only enter this loop if I'm still within the map. So this will only happen if I'm still within the map. So yeah, that was basically, I think that's the issue. I haven't submitted it yet, but I do get a new result. Let's zoom in again. I do get a new result after doing this. And as I said, I had this hunch about the turning around, that like this part. Oh wait, I'm zoomed in again. This part right here, that these would cause an issue. But I fixed that, and I got just the same amount of loops. So I was like, it wasn't that. That's weird. Like, that should have changed something. But just by pure dumb luck, that didn't fix, like, that didn't give me a different number at all. So yeah. But we ran this. We got 1767, which is smaller than the 1773 that we had before. And it did say that my number was too big. So this is a smaller number. And that's the right answer. Finally. You're one gold star closer to finding the chief historian. So yeah, that was day 6. Finally, day 6 is in the bag. So yeah, that's what I've spent the past hour and a half on. But yeah, so today, as I said, I wasn't able to do day 7. Then day 8 sort of came and went as well. And day 9. I'm not sure where day 9 went, but yeah. I've been busy. So we're back now. We're doing day 10. I'm thinking maybe like I want to do day 10. And then what if this one is quick, we'll work our way backwards and try to do more of them. And I just spotted with solving this and like waiting for the next days, it seems like we're spelling out a big number 10. And I'm guessing, is Advent of Code 10 years? Oh, no, it's not. It's 9 years old. It should be 10 next year. I think he has off by 1 or... But, well, I guess it might end like down here and say something different. I don't know. Let's crack on with day 10. The problem here is that these do tend to get harder and harder. And this might be super hard and I'll just immediately get stuck again. So we'll try to be a bit more vigilant here of the details so I don't get stuck on something dumb like day 6. Hoof it. You all arrive at a lava production facility, which apparently featured last year, on a floating island in the sky. Oh yeah, the floating islands. I remember those. As the others begin to search the massive industrial complex, you feel a small nose boop your leg and look down to discover a reindeer wearing a hard hat. Okay. The reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover that most of it seems to have been scorched by lava. Well, as you're about to ask how you can help, the reindeer brings you a blank topographic map. So a topographic map, for those of you who don't know, basically wasn't really any very good pictures of it. Basically it's like these things. So it shows heights. Yeah. So yeah, it shows heights. And it's they're really handy. Have a fun origin story as well. I'm not sure it's written here. Oh yeah. No? Okay. Never mind. Of the surrounding area, which is my puzzle input, and looks up at you excitedly. Okay. A blank topographic map. So just a blank piece of paper? Or wait, maybe just has like the height data. Like it has, not that. It has like only the topography and none of the like details, maybe. The topographic map indicates the height at each position using a scale from 0, which is the lowest, to 9, which is the highest. So here we have like a gradient going sort of up this way and a quite steep part here. And I'm guessing that this is going to be sort of pathfinding. Based on unscorched scraps of the book, you determine that a good hiking trail is as long as possible. As long as possible. Okay. And has an even gradual uphill slope. For all practical purposes, this means that a hiking trail is any path that starts at height 0, ends at height 9, and always increases by a height of exactly 1 at each step. Hiking trails never include diagonal steps, only up, down, left, right. So starting here, we can only go to left and down. And we can go to both of these because they're both 1. But if we stepped here, we could only step to this 2. We couldn't step to this 8 because the slope would be too steep. You look up from the map and notice that the reindeer has helpfully begun to construct a small pile of pencils. Pencils, markers, rulers, compasses, stickers, and other equipment you might need to update the map with hiking trails. A trailhead is any position that starts one or more hiking trails. Here, these positions will always have a height 0. Assembling more fragments of pages, you establish that the trailhead's score is the number of 9 height positions reachable from that trailhead via a hiking trail. So in the above example, the single trailhead in the top left corner has a score of 1 because it can reach a single 9. So there's only 1 9 sort of for it to reach in this map. So this has a score of 1. This trailhead has a score of 2. So it starts here and it sort of branches off and it goes to this one and this one. This one has a score of 2. The positions marked dot are impassable tiles to simplify these examples. They do not appear on your actual topographic map. Good. This trailhead has a score of 4 because every 9 is reachable via a hiking trail except the one immediately to the left of the trailhead. So here we can't go up there because it's too steep. And here we can go to this one. And we can go 7, 8. Okay, we can't go to any of those. But we can go 5, 6, 7, 8, 9. And up to this one and to this one. This topographic map contains 2 trailheads. The trailhead at the top has a score of 1, while the trailhead at the bottom has a score of 2. So this one can go to 7, 5, 6, 7, 8, 9. This one can go to this one, but it can also go this way and get to this one. As a larger example, this example has 9 trailheads. Considering the trailheads in reading order, they have scores of 5, 6, 5, 3, 1, 3, 5, 3, and 5. Adding these scores together, the sum of the scores of all trailheads is 36. The reindeer gleefully carries over a protractor and adds it to the pile. What is the sum of scores of all trailheads on your topographic map? Right. So, okay, it's kind of small. I think we'll basically just do some simple recursion here. So let's head back to, no, not part 10, day 10. Zoom it a bit. We have our example txt file, and we will create a part1.nym. So we need our map, and I mean we could parse this into a data structure of some kind, or we could just use the textual representation of it. Nah, let's do some parsing. So the map is a sequence of ints. Simple enough. Well, okay, we wouldn't have had to done it that way, but let's say we have stereotools, probably need that. Securitools, those are sort of standard practice for these. So read the file input, or start with the example. And then we want to split my autocorrect has stopped working. Oh, maybe I just need to save the file. No. That's weird. Split. Oh, there it goes. Split lines. This has a keep EOL. Let me echo this real quick. Right, so here we have all our lines. We also have this annoying sort of end line. I'm guessing that keep end of line drops that. So if we do this, no, okay. Right, if it's set keep end of line to true, then it will keep the new line character in there, right? Okay. Let's just filter it. It dot length is not equal to 0. So filter basically runs this where it for each iteration is something in the input. So here we split into lines. We get a sequence of strings. Then for each of those strings, check if the string's length is not equal to 0. If it is, then keep it. Otherwise, discard it. And then we will, I guess we can do, so we have a sequence of strings. And we want to map each of these sequence to I think that should work. Oh, no. We have no parse int for single characters. Okay, let's do this. This will of course not be the right numbers, just to check. Yeah, that looks reasonable. And then just minus the ord value of the 0 character. Now these should be the right numbers. Echo out just the file. So, well, don't have to do that. Just yeah. So here we can see the first line 890.10.103, which is the same as this one. Very good. Yeah. So basically, what this is doing, we're splitting into lines. We're filtering each line just to get rid of that last one. We could have also just said keep all but the last one. This would give us the same result. But trying to do it functionally. Then map that. So map all of these strings. So mapping takes some input and turns it into something else. In this case, we have a sequence of strings. So I write a function that works on strings and returns something else. And what I want to do, I want to map it on the string. So for each character in the string. And we turn this into a sequence of integers instead of characters. pretty nifty. So now we can basically just remove the type declaration there. So in nim, we could have done this. There's nothing sort of wrong about doing that. Do that just so it stops complaining. So there's nothing wrong about having these definitions, but you don't need them. So nim is able to see what comes out of this and automatically determines the type. So you don't need it, and it's kind of just in the way. So most people just omit them. Let me zoom out a bit so we get that on one line. Let me know if the text becomes too small. I think it looks good. Right. So we have the map. And now we want to find each of the trailheads. There. Trailheads, and let's just make this a sequence of tuples of the XY variety. And then for row in, well, for Y in map, for X in, for Y row, for X in the row, elevation, if the elevation is equal to 0, then add this trailhead to the tuple. So basically, when you give two values to a so this is a sequence of something. It doesn't have two values, so the first one is going to be the index, and the second one is going to be the row, or the actual contents. And then for each string in the contents, we do, or for each number in the inner sequence, grab the index from that, grab the actual number. If the number is 0, add the trailheads. So we have a trailhead at x2, y0, x2, y0, x4, y0, x4, y0. Yep. We have one at 4y2, so 0, 1, 2, 4 there. That seems good. Okay, so we have a way of finding trailheads. Now, for each trailhead in the list of trailheads, now we want to find our score. I'm just gonna say, so our score is 0, and then trailhead dot score plus equals the length of the trailhead. But of course this throws an error because there's no length. Trailheads don't have a length. They're just a number, or they're a tuple of two numbers. If we had done len, I think it might. No, okay. So in nim, a tuple, you can do like this, since the tuple has an x and y field. But you can also do this because it has two values, 0, 1, 0 and 1. So I thought maybe it had the length as well. But since we want recursion for this, I wanted to write a function. So the length from a position, which is a tuple of x, y, int, that's a number. So the length from this position is going to be, so let's say that the result is 1. We need to look at everything around us. We don't have to worry about sort of going back on ourselves because we can't go down. So we need to look up, left, right, and down. Look for numbers that are 1 higher than ourselves. If it is, then add our position and the length from that number. And then call the function again. And it does that all the way until it's 9. So if the map at our y, so since we did line by line and then split it into the numbers, x and y is opposite in our map. If this is a 9, then we okay, so we have our result. Yeah, so result is 1. If the number of this position is a 9, then we just return. We're done. And in them, as you might know, result is the implicit return value. So result will always have the type of your return value. You can assign to it. When you return, if it's set to something, that's the number that's going to be returned. We could have also done this, and we could have done this, but we can also just leave it and it will return the value of result. Otherwise, we need to go looking in all the directions. So we need to look, well, let's just hard code these for now. If position.x does not equal 0 and map, I can't write today. It's going to be interesting if we're going to do multiple of these. Is equal to our position. Well, if our position is equal to, I liked it the other way around. So if the position we're looking at is equal to our position plus 1, that means that this is a trailhead that we can go to. Oh, wait. So since this forks, right, this forks. Is that going to be an issue? What was the output we wanted? Right, they have scores, and the score is it's reachable via a hiking trail. This trail had a score of 2. Oh, we only care about the score of a trailhead. Right, so we don't actually care about the length because they're all are going to be the same length. So let's not call that length. Let's call it score. And if we hit a 9, then this has a score of 1, and we return. If the position x minus 0, if x is not 0, and the position to the left of us is equal to 1 higher than us, then we say that the score is equal to this score, or to the score of the position that we are looking at. If we do this, if y is not 0 and y minus 1, y minus 1 and x, like that. So if we're not at the top, we can go that way. We do. And the same thing if x is not equal to map 0 dot length, or dot high rather, and plus 1 and plus 1. And if this is not equal to map dot high, because it's a y direction, plus 1 in the y direction. Right. There is no len there. Ooh. Why is this so unhappy? Oh, we're scoring. Right. We of course want to score this position. There we go. And we store our positions the opposite way around from our map, which is a bit confusing, but we'll manage. There. Oh. There. And I didn't like calling this number score. Let's just call it total. I thought it would be fine with that, seeing how 1 is a function and 1 is a variable. Right. So basically, we go for each trailhead, we try to score the trailhead. If we hit a 9, then we return that number. Result is initially 0. It's like all variables in nim, they default to sort of all nulls, and that depending on what the type is, that's what the value is. But a null value for an int is a 0. So we add the score of this position. If it gets to a 9, then this comes back with a 1. If it hits multiple 9s, they will sort of be added together through this. And yeah, that should be. The number we're looking for is 36. 81. That's not the right number. Interesting. Okay. Let us look at trailheads here. So the first one, 20. That's higher than we would have wanted. So we're looking for these numbers. As you might tell, 20 is not in this list. So the first one should be this one. That's the first one we find. So this should be a 5. Why is it not a 5? We come in here with a position. Right, yeah. With a position, X and Y. We try to map, or we check if the value at this position is a 9. If it is, we return a 1. Let's just walk through in the example. So we're here. This is not a 9. The position X is not 0. And map position Y, position X minus 1. Is it equal to our position plus a 1? It's not. It's a 9. So this doesn't happen. Y is 0. So that's ignored. We're not at the high position. X plus 1. X plus 1 is equal to one of us, or one of our numbers. So we score from that position. Huh. I feel this should work. The problem with the recursion is that it can be hard to debug. I'm just checking that I got all my like plus and minuses right here. X minus 1, Y minus 1, X plus 1, Y plus 1. We can't move diagonally. We have these set correctly. Our score is too high. We check that these are equal to our current position plus 1. You know what? Let's just try like a super simple one. Yeah. So this one has one trailhead. Let's try this one. Should be easier to debug. So this should come out with a score of 1. 16. That's definitely not correct. Okay, so what's going on here? Echo scoring position. So we start at 0, 0. Then we go, let me bring up a second terminal here. Uh, 2024 day 10. Let's walk along with it. So we started 0, 0, 1, 0, then 2, 0, 3, 0, 3, 1, 3, 2. Oh, right. It hits the same 9 multiple times. So it comes down here to this 5. Then it goes to this 6. Then it goes to this 7. It goes to this 8. Comes to this 9. Then it goes back to this 7. Finds this 8. Finds this 9. Which is the same 9. Then goes to this 6. Finds this 7. Finds this 8. Finds this 9. Back to the 5. Yeah, you get the point. Okay, so we need to right. Let's make this a set of, actually let's copy a little thing from our friend day 6. Part 1 or 2, doesn't matter. Let's grab our position template, which now finally works. God damn it. Yeah, let's also just to be nice about it, let's grab the position as well, which is just a UN16. But then we can say that we want to return a set of positions instead. And if we find a 9, we will include the position pos x, pos y. This, I think I can include a set in another set. Otherwise, we might need to use a different operator, but that will be evident soon. We don't have map width and map height. So the map width is map 0 length, and the map height is map dot length. Here we go. Map width is still map 0 dot length. There we go. Total is 0. This must be the cardinality of the score, so how many sort of things the set contains. And that returns a 1, which is good. So basically, instead of adding a number each round, we add them to the set of sort of trail ends, I guess, a set of positions. And since all of these just find the same 9, they all just try to include the same position over and over and over, and it only ends up with a single trail. So we can see here only this 12 position is the one that's found. So now, if we just undo in our example file, bring back the larger example, we can see that we get the number 36, which seems familiar. That's the number in the for this example. So we should now be able to grab our larger input, pop it in this, pop it in here, modify our code. Don't echo out the map. You know what it looks like. Input.txt. Now run this. 550. And that's the right answer. So yeah, some simple recursion. Very nice. No comments so far, but I see there are numbers of people watching. So someone is watching. So say hi in the stream if you want. Well, yeah, if you want, I guess. You don't get anything for it. Maybe after doing day 10, so someone over on Mastodon hit me up, said they had seen one of my talks and they were considering doing NIM for Advent of Code. We had a bit of back and forth and they showed some code, and I thought we might just like go through it, just have a look at it, and sort of, I guess, a little code review kind of thing. Yeah, but let's finish up this first. The reindeer spends a few minutes reviewing your hiking trail map before realizing something, disappearing for a few minutes, and finally returning with yet another slightly charred piece of paper. The paper describes a second way to measure a trailhead, called its rating. A trailhead's rating is the number of distinct hiking trails which begin at that trailhead. Okay. So for example, this, and this. The above map has a single trailhead. Its rating is 3 because there are exactly 3 distinct hiking trails which begin at that position. Here's a map containing a single trailhead with a rating 13. This map contains a single trailhead with a rating 227 because there are 121 distinct hiking trails that lead to the 9 on the right edge, 106 that lead to the 9 on the bottom edge. Here's the larger example from before. Considering its trailheads in reading order, they have ratings of 20, 24. Wait a minute. These numbers are suspiciously familiar. This is my bug from part 1. Okay. No. Part 2. Let's see. Is it really just my bug from part 1? Is part 2 easier? Return 1. Oops. And then plus equals. Oops. Plus equals. Remove this cardinality. Run on the example. Nope. 81. 81. Yeah. I think this is the easiest part 2 I've ever had. Well, there you go. 1 gold star closer to finding the chief historian. Well, that was easy. I just had to undo something. What a strange... Huh. Would have ordered those the other way around. I'm not sure, like, how... Yeah. I guess there is some way of doing this where you do something weird for part 1, which is not what I did. That ends up making part 2 harder somehow. Not quite sure. But yeah, that's interesting. Yeah. That kind of yeah, no, I'm not, I don't know. I don't know what I'm saying. Ooh, we have some water down here. And person maybe? Yeah, I guess well, we could do day 9. We could also have a look at, well, let's start off with day 9. I want to get some of these sort of out the way. Or not out the way. I want to solve them. I want to show you some code. Oh, by the way, in this, if you're confused about this, so nim has universal function call syntax. Parentheses like this can be used to make a tuple. So what we're doing here is we're making a tuple, and because of this space, we're calling score in the same way that you would call echo, for example. So here we call echo without parentheses. So this is equal to this. Oh, not sure where that came from. Why is my Vim messing up now? What is going on? There we go. So this is equal to this, which is equal to this maybe? Or would that be, yeah, so create a tuple, score it. And yeah, this doesn't have more arguments. Like if we had 2 arguments to the score function, we could put sort of, oops, we could put 1 here, and then sort of the other on the other side. But yeah, you have command style calling, function style calling, and sort of method style calling. So you will often see me like here, we're calling the high function on map. Here we are calling the, yeah, oh yeah, here you have the, one of the last ones. So you have add, we're calling it as a method on trailhead, but in command style syntax. Could have done this as well. And the last one, I guess, could I have done this? No. That's for macros and stuff. You have you can take in blocks. I thought it might work for these as well. In this case, I guess we would have had to have been explicit. Oh, it's because it wasn't able to parse it properly. Like, you wouldn't ever write something like this. What? Why can't you score my block? Do I have to actually do this? Oh, okay. You could, of course, have done that without the block as well. Anyways, let's go back. Oops. Back up a level. Create day 9. Go into day 9. So day 10 was pretty easy. Let's hope day 9 is as easy as day 10. You were lucky. What? It's not luck. It's skill. I mean, it was literally the first way I thought about solving that, which is why I was a bit surprised in the beginning why the input was so short. Sometimes if I think like, recursion, of course, then the input just makes it impossibly hard to solve it by recursion. Yeah, that happens. But the input was short, so recursion it was. And I'm not quite sure what, like, I'm still not sure how else I would have solved that one. But yeah, if you have another way of solving it, I'm all ears. Day 9, disk fragmenter. So now we're back in time. We haven't gone to the island yet. Not that they really matter that much, or they're not really, like, the story doesn't carry on that much from one to the next. Another push of the button leaves you in the familiar hallways of some friendly amphipods. A group of amphipods. What's an amphipod? Oh, like a shrimp, I guess. Like the family shrimps belong to? Or maybe it's more specific than that. Well, back. There we go. Good thing you each somehow got your own personal mini submarine. Well, that's handy. The historians jet away in their search for the chief, mostly by driving directly into walls. Interesting strategy, kind of like my old vacuum cleaner. While the historians quickly figure out how to pilot these things, you notice an amphipod in the corner struggling with his computer. I like how we're just basically going around this place, just being IT support. Just like, oh yeah, we're just here, the historians are doing their thing, we're not really helping them. We're just solving random people's computer problems along the way. It's trying to make more contiguous free space by compacting all of the files, but this program isn't working. You offer to help. It shows you the disk map, which is our puzzle input, that he's already generated. For example, 2333, 233, 133, 121414, 13141002. The disk map uses a dense format to represent the layout of files and free space on disk. The digits alternate between indicating the length of a file and the length of free space. So a disk map like 1, 2, 3, 4, 5 would represent a 1-block file, 2 blocks of free space, a 3-block file, 4 blocks of free space, and then a 5-block file. A disk map like 90909 would represent 3 9-block files in a row with no free space between them. Each file on the disk also has an ID number based on the order of the files as they appear before they are rearranged. Starting with ID 0, so the disk map 12345 has 3 files, a 1-block file with ID 0, a 3-block file with ID 1, and a 5-block file with ID 2. So basically just adding them up. Using 1 character for each block, where digits are the file IDs and dot is free space, the disk map 12345 represents these individual blocks. So 1, and then 2 empty ones, and then 3, and then 4 empty ones, and then 5. The first example above, 233, represents these individual blocks. So a 2 long, a 3, a 3, a 3, a 1, a 3, yeah, so on and so forth. And then this 0 in there. The amphipod will like to move file blocks one at a time from the end of the disk to the leftmost free space block until there are no gaps remaining between file blocks. For the disk map 12345, the process looks like this. So like this, what? Oh, file blocks. Right. From the end of the disk to the leftmost free space. That's a very strange way of doing it, but okay. So he grabs this, puts it there. Grabs this, puts it there. Grabs this, puts it there. So on and so forth. The first example requires a few more steps. So basically always just taking from the end. Taking from the end and adding to the front. The final step of this file compacting process is to update the file system checksum, which is, I guess, my puzzle output. Yeah, to calculate the checksum, add up the result of multiplying each of these blocks' position with a file ID number it contains. The leftmost block is in position 0. What the crap? The final step of this file compacting process is to update the file system checksum. To calculate the checksum, add up the result of multiplying each of these blocks' position with a file ID number it contains. The leftmost block is in position 0. So it's 0 index, like this is block 0. Got it. If a block contains free space, skip it instead. Okay. What? It shouldn't have any free space. We're compacting. Continuing the first example, the first few blocks positions multiplied by its file ID. So it's 0, and it's the 0th file. So it's 0. 1. So position 1, block 0, still 0. Position 2. God damn it. Position 2. Number 9, 18, so on and so forth. In this example, the checksum is the sum of these, 1924, 28. Compact the amphipod's hard drive using the process he requested. What is the resulting file system checksum? Be careful copy pasting the input for this puzzle. It's a single, very long line. Ooh, very long indeed. So I'm guessing that it might be too long to efficiently be represented this way. Let's just try to write this representation first, just for fun, and see what we end up with. Like, see if I can even represent this in memory. We might not be able to. I'm just gonna do this. Okay. Our output is an empty string for I in okay, so let's do for file. So file is true, and then for character in the input. Oh, and we need the ID if file output dot add ID. Wait. What? One block file with the ID 0. The ID 2. What the hell happens when we have more than 9 files? Uh-huh. So this one has this 2.9 file at the end. But if it had one more, it would be tens. Okay. So I guess we can't store it like this. Because our input has way more than 9 files in it. Okay. That will probably make it even harder to store. Let's just store it as a sequence of integers. If it's a file. Otherwise, I'll put an add just a -1. And then file is not files, just flip file. So we go through each character, and for I in 0 ... parse int. Oh, this is the ugliest way of doing that. Let's not do that. Ord of C minus the ord of 0. It's a bit annoying that we don't have a parse int for characters, but yeah. So we have 0, 0, and then 1, 1, 1, -1. Oh, and we need to increase if we are a file, increase the ID. Right. So it's 0, 0. Then we have 3 minus 1s, which are our dots, and then 1s. Yeah. So this appears to be correct. Now let me grab this thing. Oh, I already had it open. So I have a sneaking suspicion that this is just going to be way too long. And that is going to be sort of the challenge in this one. Read file input.txt. Let me just ignore all characters. Will this crash? Oh no. Okay. Okay, so it's not actually that long? How long is this? Oh, that's no problem. Okay. So yeah, let's go back to, well, let's read in the example. I like to commit my examples. I like to commit my examples into my repository. I don't commit my inputs. But I do commit my I do commit the examples. Right. So now we basically need to go from the left. Whenever we find a -1, we grab the highest number. So we have our start at 0. We have our end at our it's gonna highlight end. End is for some reason a keyword in them. It's not used for anything, I don't think. Yeah, we can't name something end. It's not really the stop, it's just the highest number. So let's do position and highest. Bit ugly, but okay. So for I in, actually we don't need to track position, only need to track highest. For I in ID in output, so the index and the ID of our output block. We actually don't need the I either. We can do mitems. So mitems, mutable items. That means we can now modify ID. So if ID is -1, so if this is an empty spot, while output at the highest position is equal -1, decrease the highest number. When we are at this, when it's no longer a -1, then ID is equal to output highest, and output highest is now equal to -1. So basically loop through. If it's a -1, we look at the highest position. We get to, well, we decrease the highest number. If it's a -1, should only happen once or twice each loop. Then the ID is set to that number, and that number is set to -1. And of course, we need to check if ID is larger or equal to highest, break. We can actually do that here. So if we sort of, we're going from both sides of the sequence, and if we sort of cross, then we shouldn't place that number there, because then we will be sort of filling it back over itself, which would be weird. And here we end up with something wrong. Why are these not moving? So 0, 0. Yeah. 0, 0. And we move the 9s, 9, 9, 8 in. And then we have the 3 1s. Now we should move in these 3 8s. Yeah. And we have a 2. And we should move in these 3 7s. We only moved in 2 7s. And the other one got put at the end. What the crap? Just echo the output each round. Just want to see what's going on here. So yeah, first round, we're looking at this number. We're looking at this number. We're looking at this number. Good. This number, looping through these, adding in the 8s here, the 2, 7. Yeah, so the 2, we add in 7. We have backfilled with -1s, so we add in the 7 and another 7 and another 7. And 3s. Right, so this is looking pretty good. But it should have stopped here. Why did it not stop there? That's why we added this condition. What? What's your problem? Oh, ID. Oh, right. I forgot we don't have our I anymore. We should have done this all along. Wrong number of variables because we need to use M pairs instead of M items. There we go. That looks more correct. 5, 5, 6, 6. Okay, good. That looks more reasonable. And then the checksum is the position times by the value. And add it all together. So I in I comma ID and output pairs is called automatically. Checksum is I times ID and output the checksum. 1445, which is not correct. Interesting. Okay. Echo out my output real quick. Okay, let's actually just to make this easier for N in output. This will only work. This will only work since we have only single-digit numbers, but that's fine because that's what we do have. Apart from those minus ones. If n is equal to minus 1, there we go. So this, our output, is apparently not equal to this. Looks pretty equal to me. Okay. Well, that's good. That just means the checksum function is wrong. So std out write standard output dot write is basically echo without new line. You can also do write line, but those are, it's basically just normal writing to a file, and std out is just a standardly defined file. Oh, right, of course. If id is equal to -1, then continue. We should ignore the empty ones. Actually, we can break at that point because we have found the end because it's fully compacted. There we go, 1928. Okay. So we should now be able to run it on the input. And we get a big number. Put that in there. That's the right answer. Well, that's easy. I just being away for so many days, I just expected them to have gotten way harder. So I'm just expecting the output to be too big, or the recursions to get too deep, or whatever. Yeah. Upon completion, two things immediately become clear. First, the disk definitely has a lot more contiguous free space, just like the amphipod hoped. Second, the computer is running much more slowly. Maybe introducing all of that file system fragmentation was a bad idea. Yeah, that's what I thought when I said up here that this was a weird way of doing it. Open source fiddler, hello to you too. We're currently doing day 9 part 2. Got through day 10 and day 9 part 1 quite easily. The eager amphipod already has a new plan. Rather than move individual blocks, he'd like to try compacting the files on his disk by moving whole files instead. This time, attempt to move whole files to the leftmost span of free space blocks that could fit the file. Attempting to move each file exactly once. Attempt to move each file exactly once in order of decreasing file ID number, starting with a file with the highest file ID number. If there is no span of free space to the left of a file that is large enough to fit the file does not move. Okay. The first example from above. Oh, you know. Peter from Mastodon. Yeah. You're stuck on day 6. Part 1 or part 2? This is the guy I was talking about from Mastodon. IS file ID, if there's no span of free space to the left of a file that is large enough, it just move. The first example from above now proceeds differently. So these 2 9s move there. Then these 4 8s don't move because there's no 4 space. These 7s move into this slot. 6s can't move, 5s can't move, 4s can move there. and that's it. The process of updating the file system checksum is the same. Now this example's checksum should be 2850. Okay. Part 1 over to part 2. Oops, wrong button. Part 2, day 9. So I wonder if we can just do this in a brute force way, or if we actually have to be clever about this. So we definitely need to update this because we early terminated our checksum function. To run part 1 and part 2 now, we should just get the same result that we did. Part 2. Yeah. I was also hard stuck on day 6 part 2, but that was because of a super dumb bug. I'm not sure how you've solved it, but I solved mine today at the beginning of the stream, or I showed everyone how I had solved it. So yeah, I wonder if we can do this in the dumbest way possible. Just like for each ID, figure out how long it is, and then run through from the beginning and the end every time. It should be super slow, but it might work. Just grabbed some snacks for today. So yeah, they're only ever moving to the left. So if we start at the right, to the right, we're cheating a bit, consulting the almighty AI. I mean, is that really cheating? Sure, for learning a new language. Well, I mean, for learning a new language especially, I wouldn't call it cheating. Because like the alternative is just reading a bunch of docs. Like it's kind of similar to just asking someone for help. Of course, it would be nice if the AI pointed you to the docs like a real person would. And the AI isn't very good at NIM. They don't have a whole lot of NIM in their training set. So if we go from the end and we calculate contiguous spans of numbers until we hit a different number, so we go back, we have a too long, and then we go from the left, and if we find a too long span of -1s, then we can copy it there, and reset it, because it could, yeah, so in this case, for example, we are putting the 7s here, and then we're going all the way, like we're not putting the 3s anywhere, we're not putting the 4s anywhere. Oh wait, I guess we're putting the 4s over there, and then we're grabbing this 2 and stuffing it into there. So we need to restart. Okay. Let's do something here. So for I in count down from so in NIM you can do like 0.10. You can't do 10.0. You have to use countdown for that. So we want to count down from the highest number all the way down to 0. And we'll set span to 0. And ID, well, we can keep ID. ID is set to the highest ID going through this function. Or is it one higher? Oops. There. Okay, so it's one higher. So let's just decrease the ID again, so it's back to being 9. If output at this position is equal to ID, or is not equal to ID, then echo the span. Otherwise, echo the span and decrease the ID. Otherwise, do nothing. Otherwise, increase the length of the span. That should. Right. Increase span, and here we need to set span back to 0. So yeah, we have a span of 2 right there, and then we should have a span of 4. We get a span of 3, which is not correct. Then we should get a span of 3, which is a span of 4s, which is also not correct. If output I, well, so what's happening here? We start at the highest. It is a 9, so we increase the span. Go to the next one, still a 9, we increase the span. Wait. Oh. Yeah, still a 9. Now we are at the position of the 8. So span is 2. We're at the position of the 8. We see that 8 is not equal to 9. We echo out the length of 2. We set this span length to 0. We should set this span length. Right. We are not skipping the dots correctly. If we find a dot, well, we will never have like a split in our dots. So let's just set that to 1. And if output I is equal to a dot, then just continue. Oops. What? What are you on about? Oh, that's in. Oh, right. We don't have dots, we have -1s. There we go. 2, 4, 2, 4, 3, 4, 4, 3, 4, 4, 2, 3, 1, 3, 2, 3, 1, 3, and then we don't have the 2 because that's the beginning one, but we're never gonna move the beginning one anyways because that's always gonna be a file, so that's fine. Well, the code was incorrect. Oh, the code you got from the AI was incorrect? Yeah. I guess the AIs of the world weren't trained on enough NIM code, so they're not very good at NIM. I've heard that Claude apparently is better than ChatGPT at NIM, but I'm not sure how much better. I've tried a couple of times in the past, never gotten anything useful. But of course, useful for me would be a pretty high bar, because I would turn to AI to solve harder problems than like beginner NIM problems. So you might still find value even though I wouldn't. Yeah. Right, okay. So now we have our spans. So in here, instead of echoing out the spans, we want to place these spans. And for placing spans, we go from for s in 0 dot dot output, or 0 dot dot I less than I. So we don't want to move stuff to the right. Let's just try to move stuff to the left. This might be an issue, but let's cross that bridge when we get to it. If s is -1, so if this is an empty space, well, we want to do some skipping, so let's do this instead. While s is smaller than I, if output at position s is a -1, open span 0, while this is -1, increase open span and increase s if the open span that we found is greater or equal to the span that we want to place. Then for I in 0 dot dot span output at position s minus open span plus I is equal to the output. Oh, we can't reuse I here because we need it. What we're gonna call this one? Naming iterator variables. Iteration variables is so hard. I plus I, but I is not our ID, so +1. And output I plus 1 plus I is equal to -1. And let's just set s equal to I, break out of this for loop, then this for loop breaks. Oh, wait, like that. Then we don't have to set that, we can just break out. Oh, wait, we're breaking out of that loop. Yep. S is I. I think that should work. Let's echo out the output here, because we know what it's going to look like, or what it should look like. That took way too long. for the example. Prints out a 2. What's that 2? Right, okay. So it finds the first span of 2. Then it starts, increase I. Oh no, increase S. There we go. That's more what we wanted. Of course, it didn't quite do what we wanted. So it did put this 9, over here. And then the 8s stayed in place where they should have been. Then the 7s. So when it got to the 3 span of the 7s, right here, it decided to put 1 7 here and the other 7 over there. That's not right. Interesting. Okay. Let me output this after this loop here. So we can get the progression. So yeah, it finds the 2 span of the 9s, puts them there. Finds the 4 span of the 8s, leaves them in place. Finds the 3 span of 7s, and then goes bananas. So I guess it figures out that it can fit this hole, and then it copies from the wrong place. So it copies, I would assume it copies these 3 values into here. Yeah, this is what I was thinking when I wrote this. So since we just continue in this case, when we find something that is not our ID, we have already skipped past the -1s. So our I position is no longer the correct position. The I position, in this case, we go backwards through the 7s, and then we just skip this. So it's not until we're here, until we find the 6. And then we grab these 3 values, which is not what we want. So we need our sort of augmented I is equal to I, and then, well, output AI is not equal to ID AI. It's a super ugly way of doing it, but it shouldn't run that many iterations. It should hopefully be fine. So basically, when it finds another number, this is the index, go up until we find the index. Oh, and also at the end, decrease AI again, because we want to have gone 1 step too far. Oh, index defect. Right, finds the 4s, finds the 3s, places them right. So that's good. Finds the 6s, can't move those. Finds the 5s, can't move those. Finds these 2 4s, puts them in there. That's correct. Now it finds the 3 3s, and it doesn't find a place to put those. Then it goes back until it finds the 2 in 1. And then 42 is not in 0, ... 41, going from position 25. Interesting. So when this span, wait a sec. Oh, now we don't have AI there yet. Span was what I wanted there. Let's see. Right. So our ID is 39. We get down to 6, 5, 4, 3. And it finds the 4. Why on earth does that happen? Oh, right. So it sees the 4. Why does it find a span of 3 of 2 3s? That doesn't make any sense. It's basically getting confused because it doesn't find numbers. It doesn't find the numbers it expects to find. So it comes down here. It's now looking for. It's looking for 3s. Yeah, it's looking for 3s. And it got to a 4, of course. So it's looking for these 3s. Da da da. It gets to the 4. It has a span of 3 3s. And our position is 13. Then it goes one step further and sees that, and it expected this to be a 2, but it isn't. And it gets to the 4. So it says, I'm looking for 2s. The current position is at a 4, at position 12. And my span is 1 long. And then it starts looking this way for a 2. And it never finds one, drops off the edge. We get this exception. Right, that makes sense. So we basically want to skip if the input ID is smaller than is bigger than the ID that we're looking for. Also just skip past them. There we go. So yeah, now it moves these 4s over to here. It can't find anywhere to put these 3s. Now it gets this 2. Yeah, it gets this 2. Oh no, it doesn't get to the 2. Finds the 4. It moves the 4 over there. And it just stops. What? I'm an idiot. There we go. Okay, so it moves the 4. It moves the 4 to there. It can't move this 3. Now it finds the 2. 171. Got a 2. It found the 1 because it's skipping all of these. Then AI is going back to the 2, grabbing that, putting it over there. Perfect. Okay. So now this works. It's ugly as hell, but it works. Checksum 2858. That is what is expected for the example. So we can run this on our input and cross our fingers that it's fast enough to complete in reasonable time. It appears so. And that's the right answer. Okay. So that one was also pretty easy. Interesting. So yeah, ugly code. I didn't think we were going to be able to fill the memory and fill the memory with the files. Then we started doing this. I thought this is going to be too slow to like brute force our way through it. But it wasn't. And this finding back the augmented eye position of the actual thing, because we're continuing in this case, ugly. But you know what they say, if it's ugly and it works, well, no, don't write ugly code. Like if I were to revisit this like next year for Advent of Code, looking at this, trying to figure out what the hell is going on, I would not enjoy that. But it works. And we're not really writing future-proof code in these. Well, I try to most of the time, but not today apparently. Okay, so we're working our way back up. Still not sure what's going on here. Oh, you know what? This looks like the island. If I go back to last year. Oops, that was next year. Yeah, that's this island. I think it's this island. And this is another island. That's an island. Maybe this is some island stuff. I have no idea what's going on. I think we might be getting, like, since it's a Big 10 here, I think it might be doing like previous years. Like, oh yeah, this is the kind of thing that we're seeing over here, I guess. 2021. I haven't seen much of that. Oh yeah, here we have some. So this seems to be like a sort of best of montage kind of deal. Cool. Okay, so we managed to do days 9 and 10 and the second part of day 6 today. But it's getting late here and I don't think I'm gonna start doing 7 or 8. Will it be cheating if I look at them? Now that we're past today? I know the whole thing is that I try to solve them live without having looked at them. Yeah, I guess it's cheating. So yeah, these 2 days, we might revisit them later. But hopefully tomorrow I'll be doing day 11. Yeah. I'll of course add this to my GitHub. All the parts that I'm not gonna add Pietro's code for day 6. That was just for my own testing. I just couldn't figure it out. like I was on the right track, but I just yeah, there were multiple issues, and it wasn't apparent that one issue was sort of masking the other. Add day 10, the example. But yeah, I'll get all of these added to GitHub. And oh yeah, you can find my GitHub over here. Advent of Code 2024. Here you will also find a link to a playlist of all the streams. It's up to date, well, day 5, so I'll add 6 and this stream to the top of that. And I'll add day 6 and 9 and 10 as well. But yeah, I hope you enjoyed the stream. If it works and takes less than 24 hours to complete, it's good code. No, it's not. Like, sure, it works, but it might not work if you change the input, or if you want to revisit it later and use it for something else. As long as humans are writing code, the code being human readable is still important. We might not be writing code for much longer though, but that's a whole other discussion. And I don't want to use like AI summarization tools on someone else's code to figure out what's going on. Because what if the AI lies to me? But yeah, that's it for me for today. I hope you enjoyed the stream. I hope to see you back for some more streams. But that's everything